In a service-oriented architecture, part of the whole motivation here is that you can assemble large and more complex systems by putting together collections of services. The services call each other. Each service is sort of specialized to do one thing. And so you get your modularity that way. But now, if you turn to the testing side of that equation, how do you test a setup like that? So, going back to our rotten potatoes, if our rotten potatoes app is going to call out to TMDB using the TMDB API, there's this question of where would you stub those calls for testing purposes? So one possibility is, and this is what we did when we sort of developed our little example with RSpec and the request spec, is stub it at the level of the class. Our active record movie object has been given the responsibility of this method find in TMDB. It's somehow that method's job to call the API, get some results back from the API, and essentially package them up into an active record object. So one thing you can do is you can stub right there, right? And just assume that all of that will work for the purposes of your tests. You can also, so how does find in TMDB do its job of calling the TMDB API? Well, one nice way to do that job is there's a gem called the MovieDB that sort of wraps the API in a nice Rubyistic set of classes so that you don't have to deal with the raw HTTP and raw JSON. So you could also stub it there. You can actually say, allow the TMDB movie class to receive a find method with whatever string. Now, this time, what's going to be returned is something different, right? This time, you need to fake out and make something that looks like what the API would look like. And just to give you an idea of what that would be, we can actually take a look. I'm just in a Ruby command line interpreter here. I've loaded the MovieDB gem, which provides a wrapper around the API. You can find it on GitHub. One of the first things you have to do is pass it your API key, which I did. And if I now try to actually do a call, I get this big thing back. And if I sort of scroll all the way to the beginning, here's the magic character I'm looking for. Well, it's an enumerable of some kind, and it's an enumerable of TMDB movie objects. So what does one of these maybe look like? Okay, so it looks like it's an object that has these different So the TMDB API gem has its own notion of what a movie object should look like, which is not the same thing as our notion. And so another approach that I could take in my app is I could stub at the level of the API, but now I have to return something that looks like what the API would return, right? So in this scenario, the difference is that I'm including the functionality of find in TMDB as one of the things that's actually being exercised. Whereas if I stub all the way at the level of my movie class, then I'm essentially skipping over, I'm faking out find in TMDB. I'm assuming it works because for the purposes of my test, that's probably good enough. I could even go to a lower level and I could stub the HTTP calls in the Ruby library so that when the HTTP library receives a GET with whatever a URI would be to call the API, it would actually return a JSON object that looks like exactly what the API would return. So if you remember way back when we had an example of using the curl command line tool, we were doing calls against the TMDB API, and what comes back from those calls is a big JSON blob, right? So the other thing we could do is we could essentially stub at the level of HTTP, give back the JSON blob, and now whatever it is that's parsing that, like the TMDB API gem, and then that's going to pass a result back to our movie gem, all of that stuff is now going to be included in the code that's actually being run. If you're going to go this route, and there are good reasons to do that, there's a gem called WebMock that will do this for you, where you basically say, if someone tries to do a GET or a POST or whatever to this particular URI, here is the thing that you should return. Here's the HTTP status code that you should return. Here is the body of the request, usually a JSON object that you should return. So it's basically a way of stubbing right at the level of the internet. This takes you all the way to the point where you're actually doing an HTTP call, and it stubs it at that point and hands back a JSON object. And a great gem that works in conjunction with that is called VCR. VCR is a video cassette recorder. It's what we used to use to tape shows on this thing called television, which was different from streaming because shows came on at a particular time and you had to record them on magnetic tape. It was all very primitive. But VCR, the gem, takes its name from that. And the way it works is essentially the first time that you run a test case, you turn on the VCR gem, and it will record the outgoing URI and the response that you got back from the server, and it will essentially create a file that WebMock can use. So the first time you run your tests, you're actually doing the API call live, and you're having VCR record what it is, and then on every future run of your tests, instead of calling the service, WebMock will step in and it will return that canned object. And just like when we were stubbing methods where you can say, only return it if it's called with this argument, or it is an error for it to be called with a different argument or not to be called at all of those same sort of kinds of functionality are supported by WebMock. So the moral of the story here is if you're stubbing nearby, and by nearby, I mean close to your code, right? You're the app writer, so you are up here. If you stub nearby, you're getting maximum isolation of the class being tested, right? So if you're stubbing at the level of the movie class, you're isolating your test from the behavior of find in TMDB and everything under it. The TMDB API gem, the HTTP call that actually goes out to the service, all of that stuff is being swept aside. And the farther away you get, right, the farther away from your own code you get, you're getting things that are sort of more realistic because now you're testing more and more of the code path, right? And in the limit, you're testing the code path all the way to the service. And some services even provide a secondary, like a staging service or a testing service. Sometimes they'll call it a sandbox, where you can make a limited number of API calls, but the other constraints do not apply. For example, if the service charges you per API call, they may allow you to make unlimited calls to the staging server, but it only returns a limited amount of data. An example of this is if you're integrating with a payment system like Stripe, it's not a separate server, but there actually is a test mode. And when test mode is turned on, there are specific transactions that you can submit where, a particular magic credit card number will trigger a particular behavior. Like if you want the transaction to look like it failed because the card was declined or look like it failed because of an address match. So the farther away you stub, in some sense, the more realistic it is because you're exercising more code. On the other hand, that means that the tests are not as independent. They're dependent on a longer chain of stuff. They will run more slowly because you're going through more layers of code. And this is sort of the way that we think about testing in general, right? That each kind of test will find problems that others will miss. So for example, if you're writing an app that has a Stripe integration, there's a number of different kinds of things you might want to test. For example, if the idea is that the user is putting things in a shopping cart and at some point they say pay and, then they check out and they get a confirmation email, there's going to be a certain number of tests where what you're testing is, does the checkout process work? In those tests, you don't really care about the details of payment. You just want to rapidly simulate a situation where payment is successful or rapidly simulate one where the payment fails. So in that case, whatever, you probably have a model somewhere in your app that models the concept of a payment operation. You can stub that at a very high level. Like that's the equivalent of stubbing movie find in TMDB in our example. On the other hand, you probably also are going to have tests for your application where you want to make sure that your app does the right thing if payments fail. So if the user tries to pay and the credit card is declined, do you show a helpful message? Do you make sure that they don't actually get the order placed and so forth? And so in those cases, you might want to use something like WebMock because you want to make sure when I get a response from the API that says something went wrong, I want the entire code path in my app to be tested, right? That's the point of that test. So you'll probably have some integration tests that run against the sandbox so that when you're in live mode, you can actually, you can do some test transactions and make sure that the connection's working okay. You'll probably have some integration tests that use WebMock because you actually want to make sure when the API returns a particular thing, does your app respond in the correct way? And you'll probably have a whole bunch of other tests that completely stub the whole payment concept because that's not what the test out. What it's about is completing the purchase workflow or something like that. And now that we know about things like these different kinds of mocks and, stubbing, you can stub out the entire internet, we can revisit the discussion of tools like TimeCop that essentially allow you to stub the system time. Basically, they allow you to have the application believe what time it is so that you can test things that are, for example, time-dependent behavior. So how would you use something like this in a Cucumber step definition? I might write a step that allows me to say something like, given it is currently, and I could specify some date and some time, and then I just tell TimeCop to do time travel to that point. Any code after that in my test is going to behave as if that were the date. So if it tries to get the system time or anything like that, it's going to get my fake date, not the actual time of day. And something that you can put in one of the Cucumber settings files, support.rb, is you can put an after step, which basically means here's a bunch of things to do after every single Cucumber scenario is finished. And in this case, a nice thing to do would be return, meaning like reestablish the normal notion of system time. Why would you do this? This is largely because you can imagine having some tests where it matters what the date and time is because you're testing a behavior that depends on that, but a bunch of other tests where it doesn't matter. So again, you're trying to sort of selectively do the stubbing or the faking out only for the test cases that really need it. You can also use it in RSpec. For example, if you're testing that something only happens on Wednesdays, you can do time cop travel, and inside of your do block, you can put your conditions. Once the block is over, time cop will automatically return to the right time. So in terms of what we've been talking about, time cop really is just a way of stubbing the system clock in a systematic manner. And if you want to test things like something that happens after a certain amount of time has elapsed, something that's date or time dependent, basically, if you can figure out a way that it could happen in real life, you can figure out a way to stub it.